doing these swim studies with sea lamprey that have been sent to us from Michigan to understand two things about their behavior in flowing water. One is what are their swim speeds, and we do this by filming them for 1 hour following their acclimation period, by timing their individual swimming bouts, by determining the frequency of their swimming bouts, and by totaling that time in the water, so we know how long they swim, how many times they swim, and for how long they can swim during a period of time. This can be used for two main purposes. One is to determine attractive flows versus displacing flows. The other is to provide us here at ERDC with a baseline for how they behave in this tunnel, so that when we submerged a metal object in here and look at their passage through that metal object, we can determine whether or not it is being repelled or attracted. We're doing this to facilitate lamprey control measures that are being done throughout the Great Lakes Basin. In the Great Lakes Basin, lamprey are managed through an integrated program of trapping, vertical, hydraulic, and electrical barriers, and by the application of lampricides. And this is a relatively expensive effort. It's extremely successful. Lamprey have been held at about 10% of their historic levels now for quite some time. But anything that can be done to tweak that system and make it less expensive and more effective would of course help enormously. And that's what we're doing here. We're looking at whether metals can be used as a kind of guidance system to encourage lamprey to go into traps, and we're also looking at how attractive flows can be generated for optimal trap placement. There's some debate about whether or not lamprey were native to Lake Ontario, but they certainly were not native to any of the upper lakes prior to the mid-years of the 19th century. And then following completion of the Welland and the Erie canals, they invaded in a very rapid time. So by the early 20th century, they were widespread. Prior to that, they could not get over Niagara Falls. It was an impenetrable barrier to them. Lamprey are, to some extent, the vampires of fresh water. They attach themselves to fish, rasp a hole in their sides, suck out their fluids, and they can severely injure or even kill fish. They were responsible for precipitous crashes of the Great Lakes fisheries in the early 20th century. Those fisheries have recovered remarkably now, and it is partly through this very intensive integrated management program that has existed now since the late 1950s.
I was hired here at ERDC to take care of the fish in the lab. Last summer I became a student researcher working with lamprey to see their reactions to different metals. We placed the lamprey in a tank that was divided into two sections. In the divider was a small tunnel just like this, which we lined with metal. I observed the lamprey and recorded when and how often they swam through the tunnel. We tested a number of metals, including aluminum, stainless steel, galvanized steel, and brass. With galvanized steel and especially brass, the lamprey had an adverse reaction. We are hoping that by using brass, with its negative effect on lamprey movement, that we can push more lamprey into traps.
I definitely think that we could improve upon our trap design. Currently, we do use aluminum and steel for the most part, and stainless steel. We've never really looked too much at using other metals, whether they would repel or attract animals. We're not really sure how that would work out, so we're very interested to see the results of that ERDC research. Currently, the work that's being conducted by ERDC is helping us to make determinations on barrier performances, especially velocity barriers are something that the Great Lakes Fishery Commission and its control agents are greatly interested in. The public is interested in barriers that could potentially be operated seasonally, and also utilize other components or behaviors of sea lamprey to exploit, to enable them to block lampreys by minimizing the impacts on other fish species.
Beyond the research that takes place here at Hammond Bay, we also serve as a clearinghouse of sorts, providing research animals to scientists around the country who are also working on sea lamprey research questions. These can be questions ranging from very basic science, such as better understanding basic vertebrate ecology, to neuroscience, to more applied research, such as the work that's being conducted at ERDC right now, looking at swimming performance in sea lamprey. Here at Hammond Bay, we have the capacity to house about 15,000 adult sea lamprey at any one time. That housing takes place in tanks much like what you see beside me here. In any given spring trapping season, we move probably between 20 and 30,000 adult sea lamprey through the facility and redistribute those animals to researchers.
The reason ERDC is involved with sea lampreys, even despite the extensive geographic distance between us and the nearest sea lamprey, is our expertise with evaluating swimming performance of aquatic animals, and swimming performance in particular of invasive fishes. ERDC has had a long history of evaluating the swimming performance, the swimming behavior of endangered species like sturgeon and paddlefish. We have completed several studies of the invasive Asian carp, and so it was a natural evolution for us to move into the swimming performance and the behavioral responses of these fish to structures in the water. The fact is that research and management is really spearheaded by the U.S. Fish and Wildlife Service and the U.S. Geological Survey. They are the principal movers and shakers in the areas of lamprey research and management. It really underscores the fact that to successfully contain and to manage sea lamprey requires not just an integrative management approach, but also a collaborative effort by these three principal agencies.